Hello again, Internet. So, hope you're enjoying the Cerveza virus quarantine. I've been messing around for the last couple of days with this little lash up here. It's a chip I've had in my collection for ages, really. I think I bought this in like 1992 at a Radio Shack in their bargain bin for like $5. And this is, believe it or not, the first time I've ever powered it up or tried to do anything with it. So, yeah, had it in there in the collection for a solid almost 30 years, and yeah, now's the time. So this is a General Instruments AY-3-8910A. It was introduced in 1978 approximately. Used in tons of arcade machines in the early 80s, hundreds of them. Slot machines into the mid-90s and maybe even today, because there's still variant like clones of this chip out there. I think Winbond makes one. Also used in the Mattel Intellivision, which I had one as a kid. Amstrad CPC and the MSX platform, which wasn't really big in the States, but I think was fairly popular in like Japan and Asia. Some of the arcade games this thing was in include Frogger, Spy Hunter, and a game called Uncle Pooh, where you go around farting on enemies in a cave. So it's got a long and storied history in the sort of arcade sound effects realm. It has 3 square wave outputs, logarithmic 16 level volume, so you have 4 bits of volume control, and apparently if you push it fast enough you can actually do sort of a pseudo DAC kind of operation and actually get legible speech out of it. I haven't played with that, but interesting nonetheless. It has a fairly simple, kind of cheesy envelope generator. It's not like a full ADSR kind of thing like you get on a proper synth, but it actually is. It's more powerful than I would have thought just by looking at the data sheet. You can actually make some interesting sounds that start to approximate various musical instruments. And I'll go through sort of towards the end of this video, and I'll basically let this play a little loop over and over and over, and just change the flags on it, so you can kind of hear what some of those changes sound like. So this is the chip itself. Mine's a 1987 date code. I'm using a Arduino Micro, or a knockoff of one, to drive it and program it. It has 16 registers. Fairly easy to program. It generates square waves, so you basically got a period control for each of the 3 channels, a envelope control, and it also has I believe 2 noise generators in it. Here I have it set up. I just have a 4 MHz oscillator, which gets divided by 4 to get a 1 MHz reference clock. This is just a little Class D modular amplifier. I originally put this together using an LM386, but I just could not get it to stop oscillating on this breadboard. It would just go into this chop 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 kind of noise mode, and I tried putting extra bypassing capacitors on it, all that stuff. Just could not get it to stop oscillating, so I just dropped this little Class D module in where someone else took care of all the hard work. And also it's on a proper PC board, so it's not going to cross couple. I think what was happening is the output or the input was cross coupling to the gain setting pins. So because this has a lot of capacitive coupling across these pins. This is also a super cheap breadboard, and it's kind of garbage. It's pretty flaky. That's why I'm not really touching anything, because it'll just stop because of bad contact, because it's such a cheesy and cheap board. But I'll turn it up here. You can hear the little riff I've got programmed into it. It's not Super Mario music or anything like that. I didn't want to get a copyright strike for any of that stuff, but it's just a little thing I threw together. So yeah, we'll take a look at the schematic. You can hear it all getting all scratchy as I move it. So here's the schematic of it. This is our 4 MHz oscillator. It's just 2 NAND gates, 7400, connected as inverter oscillator. It goes through 2 stages of a D flip-flop frequency divider. Each one of these, for every pulse in, it generates essentially like sort of a half frequency pulse out. So put 2 of them together, you get a 1 MHz reference clock out, and that's just a 7.4 HC74. So obviously that feeds into the clock input. We have our Arduino, or your microcontroller. Back in the day, this could be like a 6502 or a 6800 or something like that. We got the bus control signals and reset, and the 8 data bits. And that will be used to program the registers. The way this works is you write into essentially an address latch. So you write out the address of the register you wanna poke into, and then you wiggle these pins in the right way. It latches it, and then the next write, when you wiggle the pins again, it will write actually into that register. So this is kind of essentially serving as a multiplexed address and data port, which is a pretty common kind of thing for a lot of chips of this sort of era and type. And on the output side, we have 3 channels. Each one generates a square wave, and I've just got them mixed together and then divided a little bit before going into a volume pot and then out to our little amp module. This is just an attenuator, and this is just to kind of tie them together. It's all high impedance going to the amp, so it's really just kind of, this just drops the level a little bit and then it goes to the volume control. And it gets a pretty decent range with what I have here. So in the next segment, I'll play some audio clips from this and an oscilloscope view and overlay the parameters that I use for each one so you can see that. That's the end of this video, and the AY-3-8910A is safely back on the foam slab of old and weird chips. I hope you enjoyed watching it, and if you did, please give me that thumbs up and leave a comment and all that stuff. Engagement helps. And you can also find the support files for this, like the Arduino sketch and a high-res scan of the schematic on my forum link, which will be in the description of the video. Thanks for watching. If you like this video and want to help support the creation of more content like this, check out my app in the Google Play Store. It's called Conversion Alchemy, and it's a calculator I always wanted to have in my pocket. With Conversion Alchemy, you can do arithmetic directly on over 170 different units using a simple and intuitive interface with high precision and lots of conveniences. Forget how many decimal places to move when going from pico to micro? Sick of reducing fractions on paper or using multiple apps with different features? Want something that has a nice advanced plain language interface but doesn't require a cloud service backend? Check out Conversion Alchemy on the Google Play Store. The QR code in the video or the link in the description will take you over there right now. And as always, if you'd like to support the channel without spending any money, hit that thumbs up button, subscribe, and leave a comment. Thanks!